Today's directions ask us to simplify rational expressions if possible. So what we're going to end up having to do is factor. That's what we always have to do. So the common mistake people are going to make on this first problem here, it's labeled number 7, is they're going to cross off the x squareds. You can't do that because it's not really x squared on top. It's x squared plus 4x minus 5. So in order to reduce, we need to factor. So I look at numbers that multiply to make negative 5. And to me, that is 5 and 1. I also know x and x are the only numbers that multiply to make x squared, so I put those numbers in there. Now, I want to have a positive 4, so I'm going to make the more positives, positive 5 and a negative 1, so that when I check the outer and inner terms, they subtract to make positive 4. So that ends up working out. Now, down below, I look for numbers that multiply to make 15. They have to add to make the 8. So it's got to be x plus 5 and x plus 3. So the whole idea here is to get the factors so that you can reduce. You see the x plus 5s will now cancel because they're factors. They're being multiplied. They're the same numbers on top and bottom, so when you cancel them, they make 1. So our answer is now x minus 1 over x plus 3. So again, the idea, you've got to factor and then try to reduce. Let's take a look at the next one here. Here we have a common factor I see. I see 3 goes into each of these numbers. So I'm going to divide each of these numbers by 3. So when I do that, here I'm left with x. When I divide by 3, those 3's cancel out, just left with that x. Over here I divide by 3 and I get a minus 4. So down over here, do the same thing. Take out the common factor. This time I see something bigger than 3 though. I see 6 goes into each of these numbers. So I'm going to take out a 6 and then see what's left over. Here I've got x squared minus 3x minus 4. Well, you're not done yet. You can reduce a little right now. 3 and 6 have a common factor of 3, so this will become a 2. But this denominator here will factor further. So let's go ahead and do that. Rewrite the x minus 4. That's what's left on top after I cancel out that 3. Still have this 2, so I'll bring that down. Draw some parentheses, and we'll try numbers that multiply to make x squared. It's got to be x and x. Numbers that multiply to make 4, but subtract to make the 3, I'm going to end up with a negative 4 and a positive 1. And so now I can reduce a little bit more. You see this x minus 4 on top? It'll cancel out the 1 on the bottom. But when everything cancels, you're left with 1. That's what you get when you cross things out, when you cancel things. They end up with a 1, and our answer would end up being 1 over 2 times x plus 1. That's the way I would leave the answer. Same sort of thing on this next one. Look for the common factor. So I'm going to go ahead and take out a 2, divide them both by 2. We've got 2, and I've got x squared minus 16 all over. Now this will factor. The denominator, we've got numbers that multiply to make 16. It's got to be 4 and 4. Numbers that multiply to make 16 but add to make 8. Got to be positive 4 and positive 4. But we're not done. See that difference of 2 squares? This term right here, this x squared minus 16, that will factor further. It factors to an x minus 4 and an x plus 4. And so from there, I'll rewrite what I've got down below. I've got an x plus 4 multiplied by another x plus 4. And the whole idea is to factor it so you can see what will cancel out afterwards. So what I have that cancels? Well, it's the x plus 4s. Cannot cancel the x minus 4 and the x plus 4 because they're different. Here I'm taking 4 away from x. Here I'm adding 4 to x. So different numbers, so I just have to leave it like that with a 2 multiplied by an x minus 4. And down below I got an x plus 4. Well, let's take a look at the next one here. Over here we've got a common factor again. You see, you can divide each of these terms by 10. So I'm going to multiply by a tenth, which is the same thing as dividing by a 10. Here I'm going to multiply by 1/5. I'm going to take out a common factor of 5. So let's put the 10 on the outside. So I've got an x squared minus 36. Over here I've got a 5 and then an x squared. Actually, I'm going to take out 1 over 5x. I'm going to take out a 5x. So I've got x plus 6. So we can go ahead and factor that difference of 2 squares. Numbers that multiply to make 36, but subtract to make 0 would be 6 and negative 6. So let's go ahead and rewrite the 10. I got an x minus 6 and an x plus 6. And then down below, I've got the 5 times by x and an x plus 6. So at this stage, we can go ahead and do some reducing. So you see how those x plus 6's are going to cancel. They're the same on the top and bottom. 5 goes into this 10 2 times. So our answer is 2 times by x minus 6 over x. And there is our answer. Well, looking at the next one, got a common factor of x here, so you can divide each of these terms by x. Always factor out that common factor. It makes the factoring easier at the end. So up on top here, I've got x plus 4 and x minus 2. The reason I got those, 4 times negative 2 makes the negative 8. The outside and inside terms are subtracting to make 2x, so it does end up working. I pulled out that x, and what's left over? A trinomial. X squared minus 2x minus 24. Well, we can factor this a little bit further, so let's go ahead and do that. Still have this x plus 4 on top, and I've got an x minus 2. But down below, I've got a trinomial, which I'm going to try factoring as two binomials. So one of the things is, they've made these problems so a lot of them do reduce. Some of them don't, but most of them do. So look at the factors that we have here. Most likely one of these is going to cancel out. So as I think about the numbers that multiply to make 24, I think of 4 and 6. You see those numbers are going to subtract to make negative 2 if I put the minus sign here and a plus sign here. You see? That way we can get those x plus 4's to cancel. So those are gone now, leaving us with our answer. X minus 2 all over x times by x minus 6. Last problem here, we've got a difference of two squares. That's going to factor as a sum and a difference, x plus 1 and an x minus 1. Down below we've got a trinomial. We'll try factoring that. We'll do a 2x and x multiplied to make the 2x squared. Numbers that multiply to make 5 would be 5 and 1. Now if I put the 5 and 1 in these locations, I won't get the 5 to multiply by the 2. See, this will make 2x and 5x. Those will subtract to make 3. To make it a negative 3, put the minus in front of the 5, plus sign in front of the 1. And then from there we can cancel out a common factor. I see x plus 1, and this x plus 1 will cancel, leaving me with that x minus 1 all over 2x minus 5. And there is our final answer. So that's the key, is to factor out the common factors, see if the factoring can be done easier. And then from there, you got to factor any trinomial or differences of squares as two binomials so you can get those common factors out of there. That's what you're going to see on tonight's homework. Good luck.